Okay, hello. We are making a video for 1350 for the foldable called numeration and computation for whole numbers. And it looks like this, but we are going to go over how to put it together. You're going to get, just a stack of handouts basically. Like 3 pages, and you have to fold it up to make a flip book. So the first page that you get, you're going to see that it has the title of the book, and then it has a dotted line where you can fold it. So you're just going to fold that one over right there. Whole number, numeration, and computation. And then the next one that you need is going to say place value, and you're going to fold it on the line so that place value is over here in front, and then you can see instructional algorithms and expanded form down there, and that's going to go inside of this first one that you folded. And we have the last one. This one has standard algorithms on one side, and on the other side it has mental arithmetic and estimation. So you're going to fold this one in half again, so that mental arithmetic and estimation shows just above standard algorithms. This one you're going to have to fold not quite on the line. Really, no matter what way you fold this, when you put them together and you straighten out the tabs, you're going to have to trim one of the tabs in here depending on how you fold it, so that you can kind of see what the name is right here. It's covering it a little bit. So we'll just take some scissors and we'll trim up the tabs out a little bit so that we can see what's underneath standard algorithms. Cut very straight. There we go. So really, just as long as you can see all of the tabs and you can see that they're in order, place value, mental arithmetic and estimations next, then standard algorithms, then instructional algorithms, expanded form, and then visual and conceptual models. And then on the back side, we're going to have order of operation, algebra tiles, lattice, and FOIL. So then once we have this to where, I really cut that cricket. Once we have this where you can see all of the tabs, it bugs me when I don't cut things straight, but you knew that already. All right, so now that it's put together, we're going to do this in a couple of parts because this is going to cover several class days. And what I have here are some manipulatives. I have colored chips and I have base 10 blocks. I'm going to use the manipulatives to illustrate the techniques in here, and then you're going to do your best to draw those into the book. So you might need some colored pens or markers. I've got like a few different colors here that I'm going to use when I write inside of mine. And I've also got a highlighter, and then I've also got the base 10 blocks, which we'll have a look at in a minute. And then we're going to use these manipulatives in class to go over things. Oh my, it looks like one of my pens had blew out. To go over things and have some examples. And that way you'll already have these little detailed drawings inside this book. So once you make it and you have it put together, you're going to want to staple it at the top, just, in 3 or 4 places. so it stays together. Try not to go crazy on the staples. All right, and so what we're gonna do first is we're gonna go to the place value tab right here. And we're gonna do this one first. So I'm gonna open this up, and so be careful when you staple it that you can see this little box right here. These chips are kind of getting in the way, and they're noisy. They sound like poker chips. Maybe I can like scoot everything on my desk over. Everything's kind of like precariously balanced here, you know. I knock everything over. And I've got a cup of water here for myself. Okay, so place value. We have here the standard form for numbers, and this place value tab is where you're going to learn how to use the correct names for numbers, or the correct nomenclature, it's called. And so we're going to have a look. I know that this little box right here is small on the camera, but you'll be able to look at it and see it. So let's write down standard form for a number. So let's see. Just a black pen will do for this. So standard form, and let's just pick a number. So 6, 3, 2, 1. So here, and when you first start teaching your students place value, you are going to teach them where to put a comma. And when we're reading numbers with these proper names, so we would call this 6,321. Oh, and I said the word and. Bad teacher. Okay, we're only going to use the word and whenever we see the decimal place right here. So don't do what I just did and never use the word and unless it's a decimal place. What I was trying to say before I messed that up was that the comma, you teach them where the comma goes, and then there's a slight pause. So the correct way to say this number would be 6,321. No and there is a little bit of a pause where we see the comma. So when you're teaching place value, this is called decomposing numbers. We are going to break down this number into its parts. Decomposing numbers. I'm going to break this number down into its parts, and at first we are going to do expanded form like this. So expanded form, and we're just going to say that this is 6,000 plus 300 plus 20 plus 1. Once we get to about 3rd grade, then we're going to start writing expanded form as 6 times 1,000 plus 3 times 100 plus 2 times 10 plus 1 times 1. And then when students get a little older, we'll go to exponential form, which is still expanded. And this is going to be 6 times 10 to the 3rd power plus 3 times 10 squared plus 2 times 10 to the 1 plus 1 times 10 to the 0. And it's going to be important for you to teach your students and for you to remember yourself that 10 to the 0 power or anything to the 0 power is equal to 1. So it's the same as saying 1 times 1, 10 to the 0 is 1. So this is going to be 4th to 5th grade, this exponential form. And then in 5th grade, we're going to start learning decimals. And so we're going to start learning how to do things on the other side of the decimal place, on the right-hand side of the word and. So our place value is going to become, let's write 1.234. Notice I said 1.234. That's kind of the math slang that we use whenever we see a decimal. But the correct way to say it would be then 1 and 234 thousandths. It's got a THS on the end of it, and the places, you count them, tenths, hundredths, thousandths, 10 thousandths, and so on. So after a while, you're going to get a little tongue-tied saying these. After a while, it sounds like you've bitten your tongue, or maybe you have like a lisp with the thousandths, you know, or you'll start spitting on your students. Try not to have a splash zone. Okay, so we got 5th grade here. This is standard form for decimals. And when we start writing out the expanded form, we're going to have the same sort of thing. There's a few ways that we can write this. Over here, when we use exponential form, we can do that again. And we'll have 1 times 10 to the 0. So that's this first one that represents the 1's position, plus, all right, this 2 is in the 10ths position. That's 1 over 10, which we can write as 2 times 10 to the negative 1 power, plus 3 times 10 to the negative 2 power, plus 4 times 10 to the negative 3 power. We can also write this in fraction form. Instead of using negative exponents, we can write 1 times 1 plus 2 times 1/10 plus 3 times 1/100 plus 4 times 1/1000. And then we can also write this in decimal form. Instead of our 1/10, 1/100th, and 1/1000th, we can write, this would still be 1 times 1 plus 2 times, I like to put a 0 in front of my decimal place here as just a good math habit so that I don't miss the decimal, that I don't like just see it and quickly go, oh, it's 1, and I don't see that it's 0.1, right? So it's a habit that I have, sometimes I don't do it, but I like to try to do it most of the time. So then we have 3 times 0.01 plus 4 times 0.001, like so. So these are some of the ways that you can expand a decimal. That would be decimal places that are on the right side of the decimal place. So remember, the decimal is where you see and. So 1 and 234 thousandths with the THS. Try not to bite your tongue. All right, so we'll have a look at this in class and we'll do some examples, but we should be good for this tab. So what we want to do now is go on to, I believe I told you in your, on your agenda that we wanted to do place value and we wanted to do the algorithms for addition and subtraction in one part, and then the algorithms for multiplication and division in another part. And so what we're going to do is go all the way to the end of the book, and we're going to go to these visual and conceptual models. So what you might want to do is kind of take a marker or a pen, and what we're going to do is go from concrete. This doesn't go through. See, these are these cool Sharpie S-note markers that are not supposed to go through to the other side, but you can see that they kind of do if you press too hard. So these are very concrete. And then as we get to the standard algorithms, which are the ones that everybody probably learned when they were in school, or your parents learned when they were in school, these are very abstract. So the standard algorithms, and so what we're doing is we're going from concrete to abstract, which is where we'll start with younger students, concrete examples with visual and conceptual models that have manipulatives that they can touch and feel and play with. And even those models you're going to see go from being more concrete to more abstract. We'll talk about that as we go through them. So we want to kind of put an arrow up here, like so, to show that we are going from concrete examples to abstract examples. So let's turn to visual and conceptual models. Over here. And we are going to start with, so what's going to happen is that I'm going to get out the base 10 blocks, and they are kind of large. They aren't going to fit on this piece of paper. You're going to have to draw them in. So we're going to start with just a little picture of what each of them is. So I've got here, well, tell me this box has units in it. Oh my gosh, I think I might have grabbed just flats. Okay. That means that I am going to have to remake this video in another part. Well, I guess we can draw them and I will show them to you in class. How about that? All right. So I kind of grabbed, unfortunately, I grabbed a bucket of base 10 blocks that only has these flats. So when I borrowed them from our classroom, I just did not notice that everything in the box was this. So this is a flat and it represents 100. Just one of these, it looks like a French fry. It's just one of these pieces. And it's called a rod or a stick. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these little tiny blocks, these little units, which, yes, are just the right size for kids to stick up their nose. So you're going to have to be careful about stuff like that. You know, maybe use your own nostril as kind of a test or not. So let's draw on our foldable. I'll just demo these in class. Let's draw the unit, and we're just going to draw that as a little square unit. And then we're going to have a rod or a stick. This is called a mat or a flat. And then there is one that is a cube that represents 1,000 units. So we're talking about place value here. The unit is 1. The rod or the stick is 10. The mat or the flat is this one. That's 100, 10 by 10. And then the giant cube is 1,000. So that one, I'm going to try to draw. The block here. Right, that's a block. Okay, so I've kind of taken up a lot of room on our addition thing here, so we're gonna have to try to fit this on here. So you might want to like squish this up a little bit. Obviously, I have not drawn these to scale. So what I did and when I drew mine is I took, so we're going to work this problem using base 10 blocks. So here's our example, 346 plus 65. So I took a color, in this case I took green, and I put the first color in green, and I represented it as 300. So that's going to be 3 mats. 1, 2, 3. 40, that's going to be 4 rods. So you can just draw like a like this, right? 4 rods and 6 units or ones. So you can use dots for those. Okay, I mean, if you want to draw out perfect little squares, that's okay, but they need to be smaller than the 100 mat, right? So 6 of these, 1, 2, 3, 4, 5, 6. All right, so that's how you represent 346 in base 10 blocks. Okay, I can't believe this bucket only has flats. I'm so ticked. Okay, so now we're gonna have, pick another color. Let's say orange. And we're gonna represent 65 in base 10 blocks. So we don't have any hundreds, but we do have 6 sticks. 1, 2, 3, 4, 5, 6. And 5 units. 1, 2, 3, 4. Okay, well, this is actually an example with regrouping. All right, so we're going to start by adding the units, and we are looking for groups of 10. So pick another color, or we can use a highlighter. So if I take my pink color here and I start counting the tens, the ones, pardon me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a group here of 10 ones or 10 units. And what I want to do, and I will demonstrate this in class and we will play with the base 10 blocks. We want to exchange these 10 units for a stick or a rod. So this is going to come over here and it's going to make us an extra rod. So far we have just a single 1 left in our ones position. So now we're going to look for a group of 10 in our sticks or in our rods. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all except the one that we added, that's another group of 10. So we are going to exchange our 10 rods for a flat. So now we have an extra flat. Now, once we are finished putting all these together, then we're going to see what we have left. And so we start looking, and in this case, because we've already done our exchanges or our regrouping, we can start out counting 1, 2, 3, 4, 400. We have 1 rod left. And we have, we should probably draw them. 2, 3, 4, 1 rod and 1 ones left. So 346 plus 65 is 411. So the reason we use base 10 blocks, and I'll demonstrate this in class, is because once you have 10 of these little sticks, you can lay them on top of this flat, and students can see that 10 sticks are equivalent to a flat. And then they can take the little tiny ones, the units, and they can get 10 of those, and they can see that it is equivalent to a stick or a rod. 100 of the little units would be equivalent to one flat or one mat. So that's why we use base 10 blocks, because it actually shows the place value in sizes that are compatible, so that you can exchange things that are exactly the same size and shape. Man, I'm bummed about these base 10 blocks. I'm just gonna have to buy a set of my own, that's all. Okay, so we're gonna do addition and subtraction. So let's see how we would do subtraction, and we're gonna do one that has regrouping. And so this is going to be called the takeaway model. Let's see, okay. So we're going to do 375 minus 88, and we're going to use base 10 blocks. So I'm going to represent one of my numbers. I'm using the green pen for this, and I'm going to represent 3 flats. Yes, flats. And then I'm going to need 7 rods. 2, 3, 4, 5, 6, 7. And then I'm going to need 5 units. All right. So let's pick another color for the next number. I think last time I used orange. Well, we're not actually going to represent, we're not going to write it underneath because this is the takeaway model. What we're going to do is try to take away 8 units from the units that we have here. So if we try to do that, 1, 2, 3, 4, 5. I only have 5 units here. I cannot take away 8 of them because I only physically have 5 of them. So what I'm going to do, and again, the students would have these rods, sticks, mats, flats, units, all available to them. I'm going to make an exchange, and I'm going to take one of these sticks. How many units are there in a stick? There's 10 of them. And I am going to bring it over here. I'm going to take it away, take it out of my, what I've laid out on my paper. Again, we'll do this in class. And I'm going to have 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to exchange a rod for 10 units. And now, can I do my takeaway model? Now, can I take away 8 units? Yes, I can. So it doesn't really matter which ones, the ones that you've drawn on here that you take away. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So all you're going to do is circle 8 of them, right? And then you are going to make some sort of mark that indicates that you are taking them away. And so what I did is I wrote that I'm taking away 8 of these units because that is what is right here and taking away 8. So that's also where I used my highlighter to show that the difference between the exchange and the takeaway. So as long as you have kind of like a different color for your exchange and your takeaway, then you can keep up with what you're doing here. So next, I want to try to take away 8 rods from what I have here. Okay, so how many rods do I have? I have 1, 2, 3, 4, 5, 6. I cannot take away 8 rods from 6 rods. So what I want to do is I want to physically exchange. So I'm going to remove one of my flats and I'm going to replace it with 10 rods. So now I have 10 rods in place of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have exchanged a flat for 10 rods. And now, can I take away 8 of these rods? Yes, now I can do it. So I'm just going to circle any 8. It doesn't matter here because when students are playing with these, they're going to physically remove them, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. This looks like the easiest way to do it to me, right here. So that is going to be gone. I'm going to take it away, and I'm taking away 8 10s this time. So I'm taking away 80. Okay, so I have taken away some of my flats, rods, and units. And with our picture, we're trying to keep track of that. This will be much easier when actually using the blocks. And we're going to see what we have left. So we end up with, let's count this up. I don't know what color you could use here, maybe orange. Okay. So I have 1, 2 of those. I have to be careful of the ones that I have exchanged or taken away. So I have 1, 2, 3, 4, 5, 6, 7, 8 of these left. So 1, 2, 3, 4, 5, 6, 7, 8 of those left. And then for my units, I have 1, 2, 3, 4, 5, 6, 7 left. 1, 2, 3, 4, 5, 6, 7. So 287 is the answer to 375 minus 88. There we go. Okay. So sorry about the base 10 blocks, but now we're going to use the chips, and I do have all of those sitting right here. You just can't see them because I'm making this video in the evening and you can only see what the lights are lighting up. So I'm going to use the chips on a big piece of paper here, and then we're going to transfer them to our foldable here. So we want to use place value cards. When you a place value card is just a big worksheet that has enough place for you to put these chips on. So you're actually going to have a packet, and we're going to do it in class. You're going to draw it with little colored dots on your foldable, right? And so the difference here is that when we start using chips, then what we're doing is having, okay, suppose this blue chip represents hundreds, and this green chip represents tens, and this orange chip represents ones. Well, this is a more abstract model, because when I start looking for groups of 10 and I start taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I start taking away 10 orange chips and replacing it with a green one, then I don't have the size of my base 10 blocks that is showing that it is an exact exchange. So this, and if you have poker chips, this works out, you know, great. They're noisy, but so are these. All the chips are going to be noisy. So we're doing exchanges, and your students are kind of taking it on faith that one of these green chips is equivalent to or equal to 10 of these orange chips. So that's what makes using the chips different than using the base 10 blocks. So let's see how we can do this same problem, 346 plus 65, which is addition with regrouping. So let's take 300. So the blue ones are going to be the hundreds place value, and then the green ones are going to be the tens place value, and then we're going to use the orange ones for the ones place value. So 340, 1, 2, 3, 4, 5, 6. Some of these are a little darker than others. I think there's like a red color going on in here somewhere. All right, so this represents 346. I hope you agree. And now we want to add 65. So 2, 3, 4, 6, 2, 3, 4. Okay, so this is our addition problem. And we are going to start looking for groups of 10, starting with our ones position. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 orange ones. That is equivalent to a single green tens chip. So like I said, with the base 10 blocks, we're going to physically exchange them. So now the orange ones are gone, and I have added this green one right here in place of those orange ones, right? Okay. Now I'm going to add my green ones. 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is a group of 10 This would represent actually 100 because it's 10 chips that are worth 10 each, because the green chips are in the tens position, and we're going to physically exchange these for a blue chip, which is worth 100. So again, students are taking your word for it here as to what the value of these is, but they can't actually see the value. They can't see the sizes like they did in the base 10 blocks. So here we go. We have 1, 2, 3, 4. That's 400. This represents 10. This represents 1. So 411. So how would I draw that in my foldable here? Well, we are going to name these places. So this is going to be the hundreds, right? And then we're going to have the tens. And then we're going to have the ones. And then I color coded mine, just like I did, with the chips. So the hundreds are going to be blue. And then the tens are going to be green. And then the orange is going to be the ones. So we're going to represent our same addition problem, 346 plus 65, this time with chips that represent place value. So we're going to have 1, 2, 300, 40, 2, 3, 4, 6, 1, 2, 3, 4, 5, 6. And then we are going to add 65. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. So now I'm going to start looking for groups of 10. And on your paper, you have to do your best to show what the exchange, looks like on paper instead of physically taking them away. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all but one of these orange chips are going to be exchanged for a green chip, right? And our green chips, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have a group of 10 right here. Those are going to be exchanged for a blue chip. And then we're going to count up what we have left. We have 4 blue chips, 1, 2, 3, 4, and we have designated that those represent hundreds. We have 10, we have 1 green chip, and then we have 1 orange chip. So here's our 346 plus 65, which is 411. And this is addition with regrouping for both methods, the base 10 blocks and with the place value and chips. So what did I want to write with regrouping? So we don't use the word borrowing anymore, because when you borrow something from someone, the idea generally is that you're going to give it back. At least if you're a nice friend and you borrow something, you're going to give it back. And so since we're not giving anything back when we do this, we're going to call both of these addition and subtraction with regrouping. Okay, so now we want to do the subtraction one. We're going to do the takeaway model again. We're going to call it takeaway with regrouping. And so it's going to look a lot like this one, with, you know, the little arrows and X's and things like that, right? And we're going to see how we do that one with chips. So let's do the same one, 375 minus 88. So we have 300, 3, 4, 5, 7, and what did I say we were doing? 375, so I need 5 orange ones. Boy, these chips are going everywhere under my computer. 1, 2, 3, 4, 5. There we go. Okay. 375. Right. I want to try to take away. Whoops, we knew that was going to happen. Chips on the floor. So we want to try to take away 8 chips, but we can't. We've only got 5. So we're going to take one of these green chips, which is worth 10 of these orange ones, and we are going to exchange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to exchange that for one of these green ones. Take this green one. Wait. Okay. Now, can we take away 8? Yes. 2, 3, 4, 5, 6, 7, 8. 8 taken away. Okay. Now I want to take away 8 in the tens position, or AD. Can't do that. Don't have enough chips. So I'm going to take one of these blue chips, which is worth 100, and I'm going to exchange it for 10 green chips. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, blue chip gone. There we go. So now can I take away 8 green chips, or in other words, AD? Yes. 1, 2, 3, 4, 5, 6, 7, 8. Gone. Okay. What have I got left? I've got 200. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 287 is my difference, right? Okay, so how do we draw this inside the foldable? Very carefully. Right? Get rid of the noisy chips. And so let's do sort of the same thing we did as before. We have our hundreds, and then we have our tens, and then we'll have our ones. So we have the blue 300, and then the green were the tens. 70, 1, 2, 3, 4, 5, 6, 7. And then 5, 2, 3, 5. And we want to take away 8. But I can't do that because I don't have 8 orange chips. So I'm going to take one of my green chips and I am going to exchange it for 10 orange chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, can I take away 8? Yes. So let's see, how did I do that last time? I used blue down here. So just, use whatever color you want. Just, try to get yourself a little bit of consistency so that when you're using these notes on an exam, you know what's going on, just so that you know what you're doing. So we're taking away 8. 1, 2, 3, 4, 5, 6, 7, 8 right here. So those are going to go bye-bye, -8. Okay, now I want to take away 8 from the tens position. We're doing the same problem, by the way, the 375 minus 88. So we want to take away 8 green chips from here, but we can't. So we're going to take one of the blue, which is worth 100, and we're going to exchange it. This is called regrouping, and that one blue chip is worth 100, so that means it's worth 10 tens. 10 times 10 is 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we're going to take away 8 of these chips, or we're going to subtract 80. So 1, 2, 3, 4, 5, 6, 7, 8. So these are going to go bye-bye. And we're subtracting 80. And that's going to leave us with 2 blue chips. That's 200. 1, 2, 3, 4, 5, 6, 7, 8 green chips, which represents 80. And we have 1, 2, 3, 4, 5, 6, 7 units, or ones. 1, 2, 3, 4, 5, 6, 7. So this is how you do 375. I said the and again. Bad teacher. 375, no and. Take away 88, 287. So this is called take away with regrouping. Okay, so these are our visual and conceptual models using base 10 blocks and place value chips. So next we want to move on to, we're going to move up one level and we're going to do expanded form. This is also all about place value. This next one, this is the one that students go home with that makes the parents go gaga. Because it's kind of being called the new math, or perhaps you've heard it called Common Core math. Well, it's not new, it's actually old. Nothing under the sun about mathematics is new anymore. It's all just the pendulum swings back and forth. And anyway, we can kind of talk about that some in class, right? And eventually, once your family and friends find out that you're a teacher, you're going to start getting emails and Facebook posts and things like that asking you to explain this nonsense because the parents don't understand it, right? Which is a good reason for you to become a parent tutor, right? And be part of the grant. Okay. So let's look at expanded forms for an addition problem. So, so we're going to call this expanded form. And we're going to do 69 plus 24. And I'm going to color code this one as well. So this one is going to be pink. And instead of writing 69, just like we did when we expanded or decomposed the numbers when we did our place value tab, we're going to call this 60 plus 9. And then we're going to take this other one, get another color, make it blue. And instead of 24, we're going to call this 20 plus 4. And then we're going to add these. All right, so let's see what we get here. We get 60 plus 20 is 80, and 9 plus 4 is 13. Now, depending on the level of your student, they might just be able to go, oh, this is 93. Got it, duh, right? But you don't have to leave it that way. You can decompose 13 into 10 plus 3. So now we have 80 plus 10 plus 3, and that's 90 plus 3, or 93. So notice that we didn't do any carrying, which is what we used to say back in the day when I was learning this. And we didn't even really do any regrouping. We just expanded the numbers and added them. So now we're going to do an expanded form for subtraction, but we're going to do one without regrouping. If you want to use, if students need a more concrete example for subtraction with regrouping, you're going to want to go back to the base 10 blocks or the chips, okay? So let's do expanded form and for subtraction, but no regrouping. All right, so this time let's do 69 minus 24. Okay, so this time we're going to have our same 60 plus 9 and 20 plus 4. But this time we're going to remember that this is take away. So we're going to be subtracting these. And so we're going to have 60 minus 20 is 40, and 9 minus 4 is 5. And we'll have 45. Now, why are we doing this way? Again, we're building up students from concrete to abstract. This is still teaching place value. They need to understand that they are subtracting 2 tens or 20 from 6 tens or 60 when they do the standard algorithm, which we're going to get to in just a bit. All right, so let's move up here and let's do something called partial sums, which is really going to fry some people's brains. Uh-oh, it looks like I got my piece of paper wet. Alas, don't get your foldable wet. Partial sums. Okay, so let's do 135 plus 257. See, I did good that time. I didn't say and. It's a hard habit to break, trust me. All right. So what we're going to do here is we're going to take our first column here, and we're going to say, okay, this is 12, and I'm going to have like a little, and this is 5 plus 7. And then we're going to take our 3 plus 5, and I'm going to, I'm using a different color, I'm using green. 3 plus 5, and we're going to write here that this is 80 because this is really 30 plus 50, right? Of course it is. And now we're going to take another color and we're going to circle the 1 plus 2, and we're going to write that this is 300 because students understand that this is 100 plus 200. And so now we're just going to add down the column. And we're going to get 2, 8 plus 1 is 9, and 3 plus nothing is 3. So notice again that we did not do any carrying, which is not the word that we would use, right? We didn't use regrouping. So now let's do partial differences. And again, we're going to do it without regrouping. If you need a model for regrouping for students, because they don't understand the more abstract ones that we're gonna get to, then go back to the base 10 blocks or the place value chips where they can actually physically make an exchange. Okay, so partial differences. And you know, you're gonna have to make decisions about how you teach this stuff and which models to use based on your grade level and where your students are, what they need. So you're going to have to, and the entire class is not going to be in the same place, are they? So you're just going to have to, you know, differentiate your instruction and figure out what works for your students. Okay, so let's do 375 minus 243. And let's do our partial differences. So here we have 5 minus 3 is 2, and I have my little squiggle column here. This is 5 minus 3. And then the next one, the last time I used green, so I'll use green again. this is 70 minus 40, right? So that's going to be 30. And then this one is going to be 300 minus 200, or 100. And now we're ready to. Now here's where, things might get a little squiggly. We're going to add these, not subtract them. We've already done our subtracting, right? So the answer to this is 132. There we go. Okay. So finally, la 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 la, ding dong, the witch is dead. We get to go to the standard algorithms. Yes. Okay, so we have gone from concrete to abstract. We're just doing addition and subtraction. And so for this one, we're just gonna talk it through on these. And we're almost done with part 1 of this foldable. Yay. So let's do 259 plus 361. Okay, so let's start in the ones column. And we have 9 plus 1 is 10. And we know the way that works is that we put the ones position down here and we regroup and we bring, so we're really bringing 10 over, right? 5 plus 6 is 11, plus 1 is 12. And what we're really bringing over here is what we're regrouping is 100. And 2 plus 3 plus 1 is 6. There we go. Let's talk it through on a subtraction with regrouping. So let's see, how about 657 minus 469. Okay, so here's where you can emphasize what you're regrouping. So instead of putting a little tiny 1 here in front of your 7, write the 17 up here and then cross through the 5 and write that you are taking 10 away. And now you have a 4 or a 40. All right. 17 minus 9 is 8. Now we want to subtract 40 minus 60, or 4 minus 6, and we can't do that. So let's cross this out and let's write 14. And then let's regroup. So we are borrowing, basically, this is a 100 that we're borrowing from this 6 and turning this into 500. And we're making this 14 tens. So 14 tens, or basically 140 minus 60, that's going to give us another 8. And then 5 minus 4, or 500 minus 400, is 100. So that's regrouping, subtraction. So we are finished now with place value, right? We did that tab, and all of the addition and subtraction from concrete to abstract models. Again, sorry about the base 10 blocks, but now that you've done this for homework, we'll be able to play with base 10 blocks to our heart's content during class. So that is going to be all for this one. It is evening and it's getting close to my bedtime. So I will bid you good night and I will see you in class to talk about these and practice these and play with some manipulatives.